The same kind of glass is produced by melting the target in the high-velocity gun experiments. It too is thrown a long way from the point of impact, as this photograph shows. The tremendous amount of energy released by the impact sends shockwaves deep into the earth and obliterates anything in its path.
Just imagine the sheer power of a meteorite hitting the ground in the Reese. This is a shatter cone, in fact, from a crater in Canada, but it shows the kind of features that we expect to see. However, this specimen comes from a crater at Steinheim, less than 40 kilometers from here, which just goes to show that both lightning and meteorites can hit the same place twice. Quite frankly, what we have here is a mess. Just look how chewed up these rocks are as a result of the impact. There's really not much left of the original sediments. We have a combination of swavite and this mixed up rock that has been almost totally destroyed by the force of the impact. In fact, this rock consists of Triassic and Jurassic sediments that have been blasted across the landscape by the force of the impact, rolled on top of themselves, and then this curtain of swavite descended down on top of them. This entire process couldn't have lasted more than a few minutes at most. Quite amazing, really.
In fact, this fracturing extends to some of the fossils we find in the rocks. This belemnite, for instance, has been broken apart by the force of the impact and then re-cemented later. The destruction even extends to the granites that lay more than half a kilometre below the surface. The temperature generated by the impact was enough to melt these and reset their radiogenic clocks, which tells us when the impact occurred, 14.7 million years ago. We can now reconstruct the events that followed this massive ejection of material. The air masses of the lower atmosphere removed by the passage of the asteroid rush back towards the crater. 20 seconds after impact, the crater has stopped growing. A transient crater has developed 15 kilometers wide and 4.5 kilometers deep. Along the rim, the excavated material reaches a height of several hundred meters. At the same time, the crater floor starts to move violently upwards. During the next 1 to 2 minutes, the ejected rock falls back to Earth, forming a kind of blanket with a radius of approximately 50 kilometers around the crater. Some larger pieces of rock are thrown more than 100 kilometers, smaller fragments up to 400 kilometers. Finally, the blazing cloud over the center of the crater begins to collapse. This red-hot mixture of solid, liquid and gaseous material falls into the crater and onto the blanket of ejecta. Huge blocks of rock outside the rim slip and fault, increasing the crater diameter to 25 kilometers. Within 5 minutes after impact, all explosive action has ceased. 6,500 square kilometers are devastated. Practically all the flora and fauna within a 100-kilometer radius of the point of impact have been blotted out. The ground is covered with a steaming mass of broken rock. Enough dust and ash has been thrown into the stratosphere to lower the temperatures in the northern hemisphere. Caught on film, a real fireball over Pittsburgh. Fortunately, the Earth's atmosphere offers us some protection against the impact of smaller objects like this one, many of which break up or hit at such low angles that they bounce off the atmosphere back into space.
On Earth, we typically find craters that are circular and shallow, primarily by modification. But it's interesting because when you go to the other planets, you find a wide range of shapes and sizes of craters. So we can learn a lot by looking at other planets like Mars. This image shows a picture of an oblique impact on Mars. In fact, Mars has more than its share of oblique impacts. We don't know why, but the point is that we do see them. And here is an example on the Earth, in this case, the Rio Cuarto impact structures in Argentina. Well, we have here an impact that occurred maybe 2,000 years ago or less, And in this case, it was not just a low angle, it was a very low angle impact, maybe 10 degrees. When you have an oblique impact, a lot of the energy that would normally go into the surface of the planet or the Earth instead goes into the atmosphere. As a result, the consequences on the atmosphere are much more severe, and the consequences on the biosphere would then be much more severe. For Rio Cuarto, we know that most of this energy did not go into the ground. The layer of sand at Rio Cuarto is only about 30 meters deep, and it looked like it just barely penetrated that layer. That means that almost all the rest, and this is with an object that is 100 meters to 300 meters across, which means that almost all that energy, the rest of that energy, went into the atmosphere. So the question is, did it change the composition of the atmosphere? Did it draw in materials, soot? Did it create more NO2, NO during the massive shower that would have been produced? We really don't know. That's why the date is so critical. If a human had been there, like the Incas, if they had been standing at the foot of the Andes waiting for this to occur, they could have seen this event coming over the northeastern horizon. It would have been silent, because don't forget, this is all going at faster than the speed of sound. And what they would have seen would have been a growing glow that eventually would have gone up about 10 degrees above the horizon, and it would have looked like a rising sun. This brilliant ball would have been leaving a trail that then would have passed. Again, it's completely silent. So now if we go down to the midsection of Argentina where this finally hits, a person standing nearby, there again would have been no sound. There would have been this entire event, the entire flash, then the enormous winds that would have pursued it, that would have sucked anything in its path into it. And then if you were 100 kilometers downrange, you would have been immersed into this fiery mass, this intense temperatures rivaling the surface temperature of the sun, 6,000 degrees perhaps, that would have engulfed a region that perhaps extended as much as 100 to 200 kilometers downrange. That would have been the history. The witnesses would have been more likely the people who would have, at least the surviving witnesses, would have been up in the uprange directions. Downrange would have been a zone of incineration.
Around 130 weathered impact craters have now been identified on Earth that range in size from a few tens of meters to over 200 kilometers. Each represents an event that would have had serious consequences for life on Earth at the time. Some may have been large enough to have had a global effect on the Earth's environment. The Earth, it seems, is at the center of a cosmic shooting gallery.
Paleontologists are accustomed to think in terms of long-term geologic processes affecting the evolution of life. And if you now suddenly tell them, well, occasionally a stone the size of a mountain falls out of the sky and produces a global catastrophe, they just don't like that. It's against their scientific religion, if you will. Maybe it looks obvious now that the craters on the moon were formed by impact, but in fact, the vast majority of scientists who studied the moon, astronomers in particular, at the time that I began this work, thought that these craters on the moon were probably formed by volcanoes. That had been the prevailing idea for a century before. The beauty of going to the moon is there's no rain, no atmosphere to speak of. And so a crater once formed lasts a very, very long time. So we have a perfect record going back 3 1/3 billion years in which we could say, here is the rate at which these things have been formed, and compare that directly to the Earth.